In this brief video, we'll summarize some properties that matrix multiplication does have. We've already seen the first property. The property we kind of defined matrix multiplication to force it to have the property of associativity. And I'm just going to assume as I write these properties that A, B, and C have the proper dimensions. So obviously, for this equality to be true, we have to be able to do the multiplication. Matrix multiplication distributes over addition. You'll see in modern algebra that just like associativity, this is very fundamental. In almost every case, multiplication ought to distribute over addition, and it does. It might seem that having both 2 and 3 here is redundant, but remember that matrix multiplication doesn't commute. So A times B plus C and B plus C times A are two totally different things, and we need different rules for each. 4. Scalar multiplication. What am I writing there? Scalar multiplication is nice. We can move it around in a product. Wherever we want. And it doesn't change anything. The fifth statement we want to make requires a definition that I be the identity matrix if I has ones down the main diagonal and is 0 everywhere else. We say the identity matrix. There are infinitely many identity matrices, one for each dimension. The identity matrix is square. It's n by n. So we've got a 2 by 2 identity matrix, a 3 by 3 identity matrix, and so on. Normally, we just write I. But if it's important to keep track of which particular I we're looking at, that is the dimension of the identity matrix, we can put it in a subscript. So I sub 2 is the 2 by 2 identity matrix. I sub 3 is the 3 by 3 identity matrix. and so on. And now we're in a position to state the fifth result. That's that A be m by n. Then if we multiply the m by m identity matrix by A, we just get A. And if we multiply the n by n identity matrix by A, again, we just get A. So I acts like 1. And that observation is going to be the underlying basis for the next section.